Okay, today we're going to talk about the different sampling methods there are. On the last class, we talked about what's called the simple random sample. It's where every group of the same size has the same chance of being selected. What it basically means is if I was taking a sample size of size 5, n equals 5, little n equals 5, what it basically means is that every group of 5 people would have the exact same chance of being selected. So that was the beginning, and we went through a few more of them today. So we'll go ahead and take a look at them. Here's some examples. I'll kind of talk you through them. So the first one reads, an ad agency gathers information about the habits of Texas consumers who live in very small towns, less than 100 adults. They randomly select 12 of these small towns and then interview all of the adults in each of them. This is number one. This is going to be our cluster sample. So letter A is going to be our cluster. Basically, what a cluster is you randomly select one kind of group, and the idea is that that group is heterogeneous, basically that they're different enough. So we picked 12 towns and then everybody in it. So we got all those people, but we only selected 12 towns. So each town was the cluster. At the start of each shift, randomly select a number from 1 to 10, choose a person that as they arrive, and then test every 10th person after that. That's systematic. What systematic is when you pick a random starting point and then you keep a regular interval after that. So every 10th person, that would be systematic. The first person selected is random. Everyone after that follows off that first random person. Next one, there are 4 employee classifications: doctors, medical staff, office staff, support staff. Randomly select 10 employees from each category. That is going to be our stratified. Stratified is where we break them into groups, and those groups are homogeneous, same in some way. So in this case, doctors, the idea is that the doctors' opinions would all be similar: the medical staffs, the support staffs, and the office staffs. So that's stratified. We break them into groups, and then we select from those groups. We actually select simple random samples from those groups. Ms. Hodge is curious about the number of hours that seniors spend writing college essays. She numbers every senior and uses a random number table randomly to select 50 seniors and gives us seniors a survey to complete. Okay, that is an SRS. That's a simple random sample. Basically, the idea is everybody goes into the gigantic hat, like I used as an example, the big hat, and then we pick out 50 names. A business wants to know what its customers think of a new product, and they think that men and women may view the product differently. A random sample of 45 men and 50 women is selected to complete a survey. Again, stratified. Here's the reason it's stratified. Because they believe that men and women have different perspectives on this. They're homogeneous to their gender. So we do random samples from each group. Last one, the Podunk School District wishes to give a survey to some of its middle school students regarding the quality of the school lunches served in the cafeteria. From the 15 middle schools in the district, 3 of the schools are randomly selected. The survey is then sent home to all of the students. Again, this is like the first one. This is a cluster. This is a cluster. And the idea is, rather than try and select random students from the 15 different schools, we pick 3 schools randomly, and then we do everyone at that school. So that's a cluster sample. So those are the ones that you really need to know: cluster, systematic, stratified, and random sample. If I want to walk through an example here, just so you can kind of see of a general, like what a free response might look like. The administration at Central Podunk High School is trying to determine the mean number of minutes spent on math homework by students at their school each week. The administration randomly selects 2 students from each of the 50 math classes on campus to obtain a sample of 100 students. The mean number of minutes spent on math homework by these 100 students is reported to be 81 minutes. So in this case, identify the population of interest. Where did we pull these from? We pulled these from students in math classes at Central Podunk High School. Now, the big thing to remember is it's the students in math classes. That's where we pulled it out of this. And if we want to be more specific, it's students in the 50 math classes at Central Podunk High School. It's not all the students there, because if there's a student there who's not taking math, they couldn't be part of our sample, therefore they're not part of our population. Identify the parameter of interest that the school administrators are trying to estimate. And what it's supposed to be is the mean number of minutes spent on homework. Identify the sampling frame. Well, the sampling frame in this case, that's a very fancy word in terms of what is the sampling method. This is a stratified sample. What I mean by that is, since we're picking 2 students from each of the 50 math classes, we've stratified it based on math class because we believe that each math class may have a different perspective on homework. So we want to break those into separate groups. The mean amount of time was reported as 81 minutes. This is a parameter statistic. It's a statistic because this is based on our sample. So that's what we talked about today. There's videos out there. Feel free to watch AP Classroom to some of this discussion. They use other examples. Khan Academy, those are ones as well. But that's going to kind of wrap up our idea of what we're doing with samples. We're going to talk about some bad things to do in sampling on Thursday.